Greetings from Team Sigma 9692. Welcome to our course on FRC sensors. Across this presentation, we will explore the four main phases. Sensors available, overview, code, and testing. Over this presentation, you will learn how to code basic robot movements with FRC sensors. The video covers various sensors. Accelerometers measure acceleration, but WPiLib supports only one-axis ones. Gyroscopes detect headings, supported by WPiLib. Ultrasonics mainly detect distance, with WPiLib backing two types. Potentiometers convert position to analog voltage, supported by WPiLib. Encoders measure motion, also backed by WPiLib. Other elements include counters, limit switches, analog and digital inputs. RoboRio supports 8 analog inputs, 12-bit integers, and up to 26 digital inputs. Accelerometers in FRC ensure precise navigation, stability, and feedback control. Integrated with WPiLib, they enable intricate maneuvers, enhancing robot performance and enriching the competition experience. Gyroscopes are pivotal in FRC, guiding autonomous navigation, stabilizing robots, and enabling precise maneuvers. Integrated with WPiLib, they ensure celestial precision and ingenuity for victory. Ultrasonic sensors guide FRC robots with acoustic precision, detecting distances for graceful navigation and collision avoidance. Integrated with WPiLib, they're indispensable for victory, offering precision and vigilance. Potentiometers in FRC finely tune robot movements, ensuring accuracy. Providing real-time data, they enable complex maneuvers. Integrated with WPiLib, they're essential for precision and control in victory. Counters are crucial in FRC, tracking events and shaping strategy. They manage resources and enable dynamic adaptation, maximizing efficiency. Integrated with WPiLib, they shape match narratives with precision and foresight. Encoders provide real-time feedback on wheel rotations, crucial for control in FRC. Integrated with WPiLib, they optimize performance and ensure precision, leading to victory with reliability. Limit switches in FRC ensure precise actions, halting motions to prevent collisions. Essential for feedback, they enable control. Integrated with WPiLib, they're vital for victory, offering precision and resilience. Analog inputs in FRC serve as versatile bridges, converting sensor signals for nuanced responses. Crucial for feedback, they enable precise control, empowering robots. Integrated with WPiLib, they're invaluable for victory. In FRC, digital inputs serve as precise gateways, monitoring devices, and conveying real-time updates for control. Integrated with WPiLib, they're indispensable for success. Next, we move on to the coding aspect of these sponsors. We begin with the accelerometer. Here we can see how to introduce the sensor and get the current acceleration. This sets the range and shows you how to create different types of motors. Here is an encode example of this sensor. This is how to introduce a linear filter. Following this, we move on to the gyroscope. Here we learn how to initialize all the different types of this. This adds the heading on the dashboard. Here we have an example of this sensor in the code. And finally, this is how to turn to a specific wanted heading. Then we progress to the ultrasonic sensor. Here we can initialize everything needed. This also reads the data in millimeters and inches. This is an encode example. As we continue, we reach potentiometers. This is the initialization, followed by how to customize it accordingly. Finally, we have how to get readings. We can now talk about counters. This part talks about the initialization, and so does this one. This is how we can read it. There is more initialization needed here. This is how we configure it. And finally, this is how we read the values. Here we can talk about encoders. First we initialize these sensors. Then we configure it accordingly. We can then read the values, and reset it if needed. Then we have duty cycle encoders, and how to reset them. Finally, we have analog encoders, and how to reset them. We can use this in a driving code, and even home a mechanism. We proceed along to limit switches. Here is a simple example. Now, analog inputs. This is the initialization and oversampling. Then comes the averaging, followed by how to read them. Finally, we have the accumulator, and end with how to obtain it. Finally, we come to digital inputs. We start with the initialization. Then we can read the values. We can also get a digital port from an analog one. There are several trigger points, and here is an encode example. We can now test this code using the FRC driver station with the sensors we just programmed. Thank you for your time from Team Sigma 9692, and please make sure to follow us on Instagram for more such informative content.